Okay, let's go through a couple more examples of using the chain rule, a few harder examples. Here I have y equals ln of 2x squared minus 1 and all of that raised to the power of 4. Okay, now to differentiate this, dy over dx will be equal to, and once again there is no product rule or anything involved here, it's always a function of a function. I have 2x squared minus 1, which is a function of ln of that function, and I have that whole function raised to the power of 4. So once again, I think of this as, you can think of it as an outside-inside rule. The outermost one is the whole function being raised to the power of 4. So I treat this like a function where I have y equals fx raised to the power n. So in this case, bring the power to the front. So I have 4 times whatever, I leave whatever is inside as it is. So I have ln 2x squared minus 1, reduce the power by 1, so that becomes 3. Then I got to multiply it by whatever is inside the bracket. So multiplied by the derivative of whatever is inside the bracket. So I had to multiply it by the derivative of ln 2x squared minus 1. Now the derivative of an ln function, I always get 1 over fx times the derivative of fx. So I have 1 over 2x squared minus 1 times that so that's the derivative of ln of this function. Then I know I had to multiply it again by the derivative of this bracket as well. So I get 1 over 2x squared minus 1 times derivative of 2x squared, that gives 4x. And if I was to clean this up a little bit, I would get 4 times 4x, so I can write this as 16x times ln of 2x minus 1, all that raised to the power of 3, divided by 2x squared minus 1. And it's really important by now that you are able to do this in one step like this. And if you were to go through in detail, then I would say first of all figure out what the derivative of ln 2x squared minus 1 is, in which case you may want to rewrite this as y equals ln 2x squared minus 1, make a t substitution for this part and figure out what the derivative of this ln 2x squared minus 1 is, and then you can write down y equals all of this raised to the power of 4 and make this a t substitution, make ln 2x squared minus 1 as a t substitution, and then go through the chain rule again. And I think you will realize how you get this answer. And actually that's a 2x squared there, that's 2x squared minus 1. Okay, let me take another example. So let's say we have y equals, okay, this is going to be, let's take the sine of ln 2x squared. And actually I raise all that to the power of 4. Let's say I raise all that to the power of 4 as well. And well, this is going to be a much harder example, and I don't think you will get anything this hard in the exam. At least I haven't seen one this difficult in the paper. But if you can do this one, then I think you'll find chain rule very easy. So in this case, once again, I have dy over dx. That's going to be equal to, so the outermost part is the function raised to the power of 4. So let's do that first. So bring the power to the front. I have 4 times whatever is inside the bracket. We leave it as it is. So sine times ln of 2x squared, and reduce the power by 1, so the power becomes 3. Then I got to multiply this by the derivative of what's inside. So the derivative of all of that. So I have the sine of some function. So the derivative of that will be the cos of the same function. So I have cos of ln 2x squared. And then I got to multiply that by the derivative of the angle of the cos function. So I multiply by the derivative of ln 2x squared minus 1, and I'll continue that one on this line. So the derivative of ln 2x squared minus 1, so that will be equal to 1 over 2x squared, and I got to so the derivative of ln 2x squared minus 1 is 1 over 2x squared times the derivative of 2x squared. So the derivative of 2x squared, that will be equal to 4 times x. And this will be the final answer, but I can clean this up, I think. And just to go through the method again, just to go through this example again, what I've done is I've take the 4 to the front, leave that function as it is and reduce the power by 1. Then I have to differentiate, I have to multiply that by the derivative of the inside part. So the derivative of sine function will be a cos, leave the function as it is, and then you got to multiply it again by the derivative of this part. So the derivative of ln 2x squared is 1 over 2x squared times the derivative of 2x squared, which is times 4x. And I think I can rewrite this as I can cancel off the 2. I get a 2 off there. I can cancel off one x term here. So I have 4 times 2. I get 8 cos of ln 2x squared times the sine of ln 2x squared to the power 3. That's that term there. And all of that divided by x. And if you can do this example, I think you'll be able to do any chain rule problem.